Yeah, this is week 5 of our training program on well intervention services. So we will be talking about the advanced Slickline Tools and Operations. My name is Benjamin Evuarafo, Training Program Coordinator, and I'm the Managing Director for Evu Oil Well Services Nigeria Limited. So please stay tuned as we continue this training. We would want to observe the safety procedures in the course of this training. Anywhere you are, please identify your muster point. Should there be any reason to move out of where you are, walk briskly to your muster point, and every other person that will be around where you are, take a head count to make sure that you're not a victim of any unforeseen circumstance that might come up. Just be observant. Trainees, this week we're moving into the advanced level of Slickline work. By the end of this class, you should be able to identify and explain advanced Slickline fishing tools, carry out gauge calibration and data retrieval correctly, know the difference between memory tools and real-time tools, and you should be able to redress tools after operations and understand simulation training procedures. So pay close attention at this point in time. This is where professionalism begins. Now, we'll be talking about introduction to advanced Slickline operations. Advanced Slickline tools allow us to go beyond simple pulling or setting jobs. They help us fish lost tools, collect data, and diagnose downhole problems. If you can master these tools, you will stand out as a professional Slickline operator, not just a helper or an assistant. Therefore, your confidence in the field depends on how well you understand these tools. So pay close attention, please. Overview of the fishing tools. Fishing tools are used to recover lost or stock equipment in the well. They either latch, hook, or strike the fish to bring it out. Common fishing tools we'll focus on today are the GS pulling tool, the GRO pulling tool, the ROS pulling tool, and the blind box. The secret to successful fishing is choosing the right tool for the job. We'll consider the common fishing tool one at a time. First, the GS pulling tool. This is the most commonly used fishing tool in Slickline operations. It's designed to pull items with external fishing nets. How does it work? You engage the fish with a downhole jar. You release it with an upward jar. It comes in different sizes to fit various neck profiles. Always make sure the GS size you picked matches your fish neck, because wrong size means a failed job altogether. The GRO pulling tool. The GRO pulling tool works in the opposite direction of GS pulling tool. It's used when you don't have enough space to jar down. How does it work? It engages the fish by upward motion. It releases by downward jar. It's the best choice in tight wells or when working around delicate completions. Remember, GRO for upward engagement, GS for downward engagement. Have that in the back of your head. The ROS pulling tool. The ROS pulling tool has a shear pin that allows controlled release. It's mainly used in high-risk fishing jobs where you must avoid getting stuck. The key point here is this: always check the shear value before the job. It must match the pulling force in your program, your design program. If it's too weak, it will release prematurely or early. If it's too strong, it may break your string. The blind box. The blind box is a solid impact tool with no moving parts. We use it to hit or knock obstructions in the well, verify depth, or drift the borehole. It's often run together with a GS pulling tool during fishing jobs. It is a simple but powerful tool. Think of it as your armor downhole. Fishing string assembly. Every fishing operation uses a standard assembly, which includes your rope socket, your stem, the jar, your knuckle joints, and then the pulling tool. Each part has a role to play here. The stem adds weight. The jar provides striking energy. The knuckle joint gives flexibility. A well-balanced string improves control and prevents tool damage. Downhole gauges overview. Downhole gauges are tools that measure pressure and temperature in the well. They are used for pressure buildup and drawdown tests, leak detection, reservoir monitoring. Always treat gauges like sensitive instruments. Handle with care, please. Trainees. Gauge calibration. Before and after each job, calibrate your gauges. You must check pressure accuracy during the calibration phase, the temperature reading, time synchronization. Follow the manufacturer's standard or your company's calibration charts. If your calibration is wrong, your entire test data becomes useless. Data retrieval and analysis. After the job, you download the data from the gauge, analyze it to see how the formation behaved, pressure buildup, leaks, or any abnormalities. Always make sure your time clock matches surface records for correct analysis. If time doesn't match, your data curve will lie to you. Memory tools versus real-time tools. Memory tools store data internally, and the advantage of memory tool is this: it's simple and durable, while the real-time tools send data instantly to surface immediate feedback is the advantage. Think of memory tools as a recorder and real-time tools as a live camera feed. See the difference? The memory tool, they are more of a recorder, while the real-time tools are live camera feed. You see it live, real-time. Examples of memory tools. Memory tools include the pressure temperature gauge, the caliper tools, the downhole cameras. This can run on Slickline or coil tubing and store information for later download. They are your go-to tools for non-electric simple data runs. Example of a real-time tool. Real-time tools include electric line, E-line, gauges, live tension and depth readouts. These tools transmit data instantly, allowing real-time decisions, but they require electric power and surface telemetry systems. Plan your job logistics before using them. Power and connection are everything. Tool redress overview. Yes. After every job, inspect and redress your tools. This means clean thoroughly, replace frayed O-rings, sharpens, and damaged parts. Reassemble and pressure test before the next run. Never skip redressing. Is this reason some operators have zero tool loss records. The GS2 redress procedure. Follow these steps carefully. Disassemble and inspect all parts. Clean with solvents or diesel. Replace worn parts and lubricate moving sections. Reassemble correctly. Perform a function test before sending it to the field. If it doesn't function on the table, it won't work downhole. That is the rule. Downhole simulation training. Our simulation lab is designed to give you a real field feel. Here you practice latching, unlatching, jarring, fishing, and recovery exercises. Make mistakes here, not in the field. And that's why we train before deployment. In any of your units, there is a place to test or function test this equipment to simulate before you take them to the field. Typical simulation setup. The simulator includes a surface test wearable, partly transparent. If you don't have anyone in your location, try to meet any of these Slickline or well intervention company. They will show it to you. A Slickline unit, a pressure control stack, sensors and recorders. You will see in real time how your jarring and tool response affect downhole performance. Safety in advanced Slickline operations. Safety is your number one job. Always remember. Test your pressure control equipment before use. Lay hands on this API, American Petroleum Institute ROP 53 bulletin. You see the standard there on safety in advanced Slickline operations. It's clearly stated there. Communicate clearly with your crew. If you're a supervisor, never go to the wellhead without personal protective equipment, otherwise known as PPE. Case study here, lost gauge recovery. A memory gauge was stuck after a test. We used a GS pulling tool supported with a blind box. The gauge was successfully retrieved. Lesson learned here is this: proper planning, correct tool selection, and teamwork led to this success. Summary and review. Let's wrap up. Advanced Slickline tools make fishing and diagnostics efficient. The main fishing tools excuse me, are GS, GRO, ROS, and blind box. Always calibrate gauges and redress tools. Safety and simulation practice build confidence. I sincerely hope you follow through in the course of my lecture, because I wasn't that too fast. I was moderate in my presentation. So anything you don't understand, feel free